Hello guys, welcome to my YouTube channel Physics Prince. My name is Deepak. I'm going to teach you all 9 subjects of physical science in detail. My courses are absolutely free of charges. My courses are going to help the students who are preparing for CSIR, NET, GATE, NT exam, PhD exam, SET exam, Tifr, Jest, IIT-Jam and other exams related to physical science. Okay, so this is the 10th part of the series of CSIR NET Physics 2021 paper solution. So I'm solving part C questions because part B questions are completed. Okay, and also guys, I would request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures which are going to help you to crack the exams related to physical science. And also guys, please share my lecture details with your friends so that they will also be able to watch my free live lectures and will be benefited from it. Okay, so let's get started. Okay, meanwhile, just let me check whether I'm audible or not, and then I'll proceed further. Okay. Okay, meanwhile, just let me check. Yes, I'm audible, so I'll proceed further. Okay, so question is, these are part C questions, guys. Okay, so the pressure, it's a good question. Okay, the pressure, the pressure, the pressure of a gas, a pressure of a gas, pressure of a gas in a vessel, in a vessel, pressure of a gas in a vessel needs to be needs to be needs to be maintained needs to be maintained needs to be maintained between needs to be maintained between 1.5 bar 1.5 bar to 2.5 bar 2.5 bar in in an experiment in an experiment. The vessel is the vessel is the vessel the vessel is fitted with the vessel is fitted with a pressure transducer pressure transducer pressure transducer pressure transducer that generates that generates that generates 4 milliampere 4 milliampere to 20 milliampere 20 milliampere current 4 milliampere to 20 milliampere current for for pressure for pressure for pressure in the range for pressure in the range 1 bar to 5 bar. Okay, so there is a pressure transducer that generates 4 milliampere to 20 milliampere current. Okay, for pressure in the range 1 bar to 5 bar. Okay, the current output of the transducer, the current output, the current the current output of the output current output of the current output of the transducer of the transducer has a linear dependence linear dependence has a linear dependence on the pressure on the pressure. The reference voltage the reference voltages the reference the reference voltages the reference voltages the reference the reference voltages V1 and V2 in the V1 and V2 in the comparators in the comparators comparators in the circuit in the circuit in the circuit shown in the figure above shown in figure above shown in figure above suitable for suitable for suitable for the desired for the desired for the operating conditions desired operating conditions desired operating conditions are are respectively options are given. Option number A, that is 2 volt, option 2 volt and 10 volt. Option B is 2 volt and 5 volt, 2 volt and 5 volt. Option C is 3 volt and 10 volt, 3 volt and 10 volt. And option D are 3 volt and 5 volt. Okay, So this is the question. I'll explain the, okay, first I'll make a figure, okay, and I will explain the question. After that, I will solve it, okay. Okay, so the figure is, the diagram is given. There is, this is plus, this is minus, this is plus, this is minus, okay, and there is a voltage which is given V2, and there is a voltage which is given, this is minus, okay, V1, okay. This is given like this one, this one, and this is the, this is the figure given, guys, okay. So this is 5 500 ohm, and this is, guys, overpressure indicator, over pressure overpressure indicator, and ready pressure ready pressure ready. Okay, so this is the question which is given. Very good question, guys. Okay, okay. So I'll explain the question first, and after that I will solve it. So this is one. The pressure of a gas in a vessel needs to be maintained between 1.5 bar to 2.5 bar. Okay, so there is a the pressure of the gas in a vessel. Okay, so in a vessel there is a pressure, okay, of gas. So in a vessel there is a gas, and that pressure needs to be maintained between 1.5 bar to 2.5 bar. Okay, that should be the pressure of the vessel. Okay, in an experiment, the vessel is fitted with pressure transducer that generates 4 milliampere to 20 milliampere current for pressure in the range 1 bar to 5 bar. Okay, okay. So the vessel is fitted with a pressure transducer. Okay, so vessel is fitted with pressure transducer. Okay, that generates 4 milliampere to 20 milliampere current for the pressure range 1 bar to 5 bar. Okay, so this generates the pressure transducer, okay, that generates uh, current from 4 milliampere to 20 milliampere, okay, for the pressure range that is 1 bar to 5 bar. Okay, the, the current output of the transducer has a linear dependence on the pressure. So the output current is uh, dependent on the pressure that is given. Okay, the reference voltage V1 and V2, you need to find out the reference voltage V1 and V2 in the comparator in the circuit shown in the figure above. Okay, so this is the circuit which is given. Okay, so these are V1 and V2 which we need to find out. Okay, compare it in the circuit shown in the figure above, suitable for the desired operated conditions are respectively. So what should be, because what should be the minimum voltages of this one? Okay, what should be the reference voltages V1 and V2? That we need to find out, and provided the pressure in vessel uh, must be between 1.5 bar to 2.5 bar. Okay, so this is the question, guys. So I'm going to solve it now. Okay, so first we have been given this one. Okay, so we have been given 4 milliampere. This is given. Okay, 4 milliampere to 20 milliampere, 20 milliampere current. This is given. Okay, current for pressure, for pressure, for pressure in the range, in the range, pressure in the range 1 bar, 1 bar to 5 bar, 1 bar to 5 bar. Okay, 1 bar to 5 bar. So 4 milliampere to, so for the pressure of range 1 bar to 5 bar, there is a current of 4 milliampere to 20 milliampere. So from this statement, we can say 1 1 bar corresponds to 1 bar, 1 bar that is pressure. Okay, 1 bar corresponds to 4 milliampere. Okay, 4 milliampere. Okay, so from this statement, because this is given that 4 milliampere to 20 milliampere current for the pressure in the range 1 bar to 5 bar. So it means for 1 bar pressure corresponds to 4 milliampere. Okay, so this means, so one for 1 bar corresponds to 4 milliampere, means 1.5 bar will corresponds to 1.5 bar will corresponds to 4 milliampere into 1.5 bar, right? So 4 into 1.5, right? That milliampere. So if you calculate it, so this value is going to be this one, 6 milliampere, 6.0 milliampere, right? Right. So so this one, so 1.5 bar corresponds to 4 into 1.5, that is 6 milliampere, right? So from here we have current got, that is this one, so we can get, that implies we can get V1, V1, this one V1. Okay, V1. So we can get V1. So V1 is going to be equal to current into the voltage equal to current into I1. We can say this, let's say this is I1. Okay, so I1 into R. R is given in the question, right? R is given, that is 500 ohm. So this is going to be 6 into R, 500. So we will solve it. So this value is going to be 3 volt. Okay, it will be millivolt, and then it is 3 volt. Okay, 3000 millivolt, and that is 3 volt. And similarly, 2.5 bar, because guys, this is the question. Okay, so this one, the vessel needs to be maintained between 1.5 to 25 2.5 bar. Okay, so V1 we have got. So for 2.5 bar, current is going to be 4 into, for 1 bar is 4 milliampere, right? For 2.5 bar, 4 into 2.5, and that is going to be 10 milliampere. 10 milliampere. Okay, 10 milliampere, and this is I2. So V2 is going to be this one. V2 means V2 equal to I2 into R. I2 into R, right? R is this resistance. This is pressure transducer and the vessel, right? So this is 5,000. It is 5,000, right? 5,000 or 500. Let me just check. It's 500, guys. Okay, 500. 500 ohm. 500 ohm. So I2R is going to be I2 into R. This is going to be I2 value is 10 milliampere into R is 500, right? So this value is going to be, in volt, it is going to be 5 volt. 5 volt. 5 volt. Okay. So V1 value is 3 volt and V2 value is 5 volt. So which option is matching, guys? So option D is matching. 3 volt and 5 volt. Okay. So this is how we get these values. So I would request you, please practice this question, revise this question. Okay, it's a good question and very simple as well. Okay, so this is how we solve it. So as per question, we've got that for 1 bar corresponds to 4 milliampere. Simple, right? So for 1.5 bar, it is going to be 6 milliampere. For 2.5 bar, it is going to be 10 milliampere. Then we can easily find out V1 and V2 value. Okay. Okay, guys. So good. Next question I'm going to solve. Next question. This is also a good question, and this question is from statistical mechanics. Okay. So question is, the energy levels, the energy levels, the energy levels, the energy levels of a non-degenerate, energy levels of a non-degenerate, okay, so which are not generated. Okay, so the energy levels of non-degenerate quantum system non-degenerate quantum system are En, that is given Ne naught, En equal to Ne naught. Okay, so the energy levels of non-degenerate quantum system are this, where E naught is a constant. E naught is a constant, and N equal to 1, 2, 3, so on. Okay, at temperature T1, at temperature T, the free energy F, the free energy F, that is Helmholtz energy. Okay, Helmholtz free energy F can be expressed can be expressed in terms of in terms of in terms of the average energy E, the average energy the average energy the average energy E by, okay, so options are given. Option A is E naught plus ET ln E upon E naught. Option B is uh, E naught plus 2 kT ln 2 kT ln E upon E naught. Option C is E naught minus kT ln E upon E naught. And option D is E naught minus 2 kT ln 2 kT ln E upon E naught. Okay, so this is the question. It's a good question. Okay, so I'll explain the question first, and after that I will solve it. So question is, the energy levels of a non-degenerate quantum systems are En equal to n E naught. Okay, so energy levels of non-degenerate quantum system, we have given energy levels, okay, or energy eigenvalue have been given, that is En is given, okay, where E naught is a constant and n is that integer from 1 to infinite, okay, 1 2 3 so on. At temperature T, okay, the free energy F can be expressed in terms of average energy. So at temperature T, we need to find free energy F, that is Helmholtz free energy, we need to find out in terms of the average energy E. Okay, so this is the question. So I'll solve it. So for solving this, first we'll find partition function, okay, and after that we can find this Helmholtz free energy, okay, with average energy. Okay, so how we are going to solve it, I'll explain now. Okay, so since we have been given that energy levels of non-degenerate quantum system, okay, we have been given, this is energy eigenvalue En is given, E naught is constant, guys, okay, E naught n E naught okay, so this is what we have been given, okay, and where n equal to 1 2 3 so on. Okay, so from here we can find out E1 is going to be E naught 1 into E naught, right, and E2 is going to be 2 into E naught, E3 is going to be 3 into E naught, and so on. Okay, oh, now we'll find partition function. So partition function Z equal to, we know, right, that is sigma I, partition function is sigma I gi e to the power minus beta ei, right, this is the partition function formula, guys, you need to note down. Okay, so Z equal to sigma I gi e to the power minus beta ei. Okay, beta ei. Okay, so degeneration, because it is given in the question, right, non-degenerate quantum system, it means degeneracy is 1, right, so this partition function for this is going to be Z equal to this one 1 into, or 1 into 1 into e to the power minus 1 into e to the power minus beta EI, right? So we have energy level like this one, E naught, 2 E naught, 3 E naught, 4 E naught, so on. Okay, so this is going to be beta minus beta E naught plus 1 into e to the power minus 2 beta E naught plus, because degeneracy is 1. Okay, 1 into e to the power minus 3 beta E naught plus so on, right? So z is going to be, we'll take e to the power minus beta E naught common. Okay, if we take this common, so this is going to be 1 plus e to the power minus beta E naught plus e to the power minus 2 beta E naught plus so on, right? This one. Okay, so now z is going to be e to the power minus beta E naught. This is this we can find out, right? So this is a series, and this and this sum of this series is going to be, because it is like this one. So the sum is going to be 1 into 1 minus e to the power minus beta E, right? If we have this solution like this, we know 1 upon x, 1 plus x square plus so on. So this series, so sum is going to be 1 upon 1 minus x, right? In this way. Okay, so z value is going to be e to the power minus beta E naught. So we can divide it. Okay, we can take this side, right? So this is going to be, we can take in denominator. So this is going to be this one, and this value is going to be 1 upon e to the power minus beta E naught, beta E naught minus 1. Okay, so this is the one. Okay, this is e to the power minus beta E naught, or we can write this 1 upon e to the power beta E naught, right? So this is going to be e to the power beta E naught, e to the power beta E naught minus. Okay, so this is the partition function, guys. Okay, partition function. Okay, now next is, so we have a formula, guys. You need to note down. Okay, now we'll find Helmholtz free energy. Okay, Helmholtz free energy. So Helmholtz 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 free energy. Helmholtz free energy. This formula we know, right? A or F equal to, this is very it is just, the formula is KT ln z, KT ln z, or KBT ln z. Okay, I'm writing K is a Boltzmann constant. Okay, instead of KB I'm writing K. Okay, so this is F, K is Boltzmann constant, so F equal to minus KT ln z, KT ln z. Okay, so simple, now F is going to be minus KT ln z, ln z ln Z values we have found, right? This is so 1 upon e to the power beta e naught minus 1, right? So we'll solve it further. So this is going to be, we can write this e to the power, we'll use log property here. Okay, so if we use log property, this one, so we can write this e to the power like this. I'll write it et ln e to the power beta e naught minus 1 to the power minus 1. So minus minus is going to be plus. So this will be plus et ln, and we can write like log a minus b, right? So this is going to be this one, e to the power beta e minus ln 1. Ln 1 value is 0, so I can write like this. Okay, this value is going to be kt ln e to the power beta e naught. Okay, okay, so this is the one. We can write like this, or we can write this, just one, this one. So minus minus is going to be positive, right? Log value, log m to the power n is n log m, right? So this is this, and ln e to the power beta e naught minus 1. So this is the value of f, guys. Helmholtz free energy. Okay, so this is the value. This is kt ln e to the power beta e naught minus 1, e to the power beta e naught minus 1. Okay, let's say this is equation number 1. Now we'll find average energy. Average energy is given, that is E, right? So E is going to be, E is average energy, right? This one. This is given, and this formula we know, guys. That is minus. Okay, just wait, guys. Okay, just give me 130 seconds, guys. Okay, 130 seconds. Just. Okay, guys. So I'm going to. So just is going to be. Okay, so average energy is going to be. Average energy is going to be. So this one, average energy is, there's a formula, guys, minus del upon del upon del beta ln z. Okay, so this is the formula you need to note down, minus del upon del beta ln z. Okay, minus del upon del beta ln z. So now we'll put the value. So this is going to be, E is going to be, E is the average energy given, okay, in the question, E. So this is going to be minus del upon del beta ln z. So ln z value we know, right? So ln z value is z value is that is e to the power minus e to the power beta e minus 1, right? This one I'll show you. This is the this is the z value, right? This one. So this is going to be 1 upon e to the power beta e naught minus 1. Okay, so e to the power beta e naught minus 1. Okay, so this is the one. Or we can write minus minus will be plus, so we can write this ln e to the power beta e naught minus 1 to the power minus 1, right? So this is going to be minus minus plus and minus plus, so this will be del upon del beta ln e to the power beta e naught minus 1. Okay, so this is the e. Okay. Next is okay, now we'll differentiate it with respect to beta. So this is going to be e, value of e is going to be e to the power beta e naught into e naught upon e to the power beta e naught minus 1, right? How? It's simple differentiation, guys. 1 upon log t is, so log t, suppose it's 1 upon t, right? So 1 upon e to the power beta e naught minus 1, and then differentiation of this e to the power beta e naught, right? So this is going to be e naught, e to the power beta e naught, right? So this is the e, average energy we have got. So from here we can write e to the power beta e naught minus 1. This value is going to be e to the power beta e naught so this is going to be e naught upon e. This is average energy. E is the average energy. Okay, e naught is the constant. E to the power beta e naught. Okay, let's say this equation is 2. This one. So now what we can do is, so this value we can put in equation 1. This is the equation 1, right? Because we need to find out Helmholtz free energy in terms of average energy, right? So this is the Helmholtz free energy, this one, equation number 1, kT ln e to the power beta e naught minus 1. So e to the power beta e naught, in place of e to the power beta e naught minus 1, we can write this e naught upon e to the power beta e naught, right? So this is going to be so if you put the value, so F, that is Helmholtz free energy, that is going to be kT ln, and instead of this value, instead of e to the power beta e naught minus 1, we can put this value e naught upon e ln e naught upon e ln e naught upon e e to the power beta I naught. Okay. This one. Now we'll solve it. So the F is going to be Helmholtz free energy is going to be F is going to be F is going to be KT ln. So now we can write this like this. Okay, so this is this one ln this value, right? A into B. So ln A into B we can write ln A plus ln B. So ln e to the power E naught plus ln e to the power beta I naught, right? So F is going to be this one KT ln E naught upon E naught upon E ln, it is common, ln this one E beta ln E beta E naught. Okay, this one. Now F value is going to be F equal to KT ln E naught upon E plus, this is important thing guys, so ln E beta E naught, so ln E naught will get cancelled, so this value is going to be beta E naught. This is simple log and exponential property, right? So this value ln E value is 1, right? ln E base E, right? This is 1, so this is beta E naught. So value of F is going to be, or we can write this like a beta value we know guys, right? Beta equal to 1 upon KT, right? K is the Boltzmann constant, so we can write KT ln E naught upon E plus in place of beta we can write E naught. This we can write E naught upon KT. Okay, now so we need to, because we've got the answer, but we have to make this answer as per the question. Okay, as per the options. So these are the options guys. So let's see. Okay, this we can make that expression in terms of the as the option C. Okay, so this is going to be KT ln. So value of F is going to be, I'll write in next page. So this one. This is going to be, we can write F equal to we can write this E naught, KT will get cancelled for this, right? E naught into, and this we can make we can use log property, so minus ln E upon E naught we can write it guys. Okay, so ln E naught upon E we can write it is equal to minus ln E upon E naught, right? So this is the answer guys, and KT is also there, so this is going to be KT ln E naught upon E. Okay, sorry, my apologies, KT ln E upon E naught, E upon E naught, E upon E naught. Okay, so this is the answer guys. So option C is matching, right? Option C is the correct option. This one E minus KT ln E upon E naught. Okay, so this one E minus E naught minus KT ln E upon E naught. Okay, so this is the answer. I hope guys you have understood it. It's a good question and 5 marks question guys from statistical mechanics. Okay. 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 Next question guys. Next question is Next question is, this question is from classical mechanics, okay, central force problem. Okay, so question is, a particle in two dimensions, a particle in two dimensions, a particle in two dimensions, a particle in two dimensions is found, a particle in two dimensions is found to trace, particle in one dimensions is found to trace an orbit, r, which is function of theta, equal to r naught theta square. That is the equation of orbit given, right? If it is moving under, if it is moving under, under the influence of, a central potential, central potential influence of central potential VR equal to C1 r to the power minus a plus C2 r to the power minus b, where r naught C1 and C2 are constants, of appropriate dimension, appropriate dimensions, the values of a and b respectively, are option A is 2 and 4, option B is 2 and 3, option C is 3 and 4, option D is 1 and 3. Okay, so this is the question, guys. I'll explain this question and then I'll solve it. Okay, so question is, a particle in two dimensions, okay, particle in two dimensions is found to trace an orbit Okay, a particle in 2 dimensions is found to trace an orbit. Orbit equation is given r, which is function of theta equal to r naught theta square. Okay, if it is moving under the influence of central potential, okay, Vr, we have been given Vr equal to C1 r to the power minus a, C2 r to the power minus b, where r naught, C1, C2 are constants of appropriate dimensions. Okay, the value of a and b respectively are. So we need to find out value of a and b. Okay. Okay, let's get started. Okay. So it's a good question, guys. Okay, so we have been given orbit equation, guys. Orbit equation is given r, which is function of theta, r equal to r naught theta square. Okay, so this is the orbit equation we have been given. Now this is given. Okay, and since we know that r is 1 upon u, right? Or we can write, since u equal to 1 upon r, or r equal to 1 upon u, right? We have studied in this classical mechanics. Okay, in central force problem. So this is going to be, we can write, this implies u is going to be 1 upon r, and 1 upon r value is 1 upon r naught theta square. Okay, now so we have this. Now we can write, let's say this is equation 1. Okay, now we'll write du upon d theta. Du upon d theta is going to be, this value is going to be minus 2 r naught theta cube. So we have just differentiated this expression with respect to theta, right? Simple differentiation. Theta will go up. Okay, and theta to the power minus 2 into n minus theta to the power n into n minus 1, right? Theta 2 into theta to the power minus 3, right? So that theta to the power minus 3 will come into denominator, then this is going to be theta to the power 3. And similarly, now we'll differentiate again with respect to theta. So this is going to be del square u upon del theta square. So this is going to be minus, this value minus plus. So this is 6 upon r naught theta to the power 4. Okay, so 6 upon r naught theta to the power 4. I can write like this: 6 upon r naught, 6 upon r naught, 6 upon r naught theta to the power 4. Theta to the power 4. R naught theta to the power 4. Okay, so this is the equation 2. Okay, so now we know this differential equation of the orbit, right? The differential equation for the orbit we know, so we'll write it. So differential equation of the orbit. So differential equation of the orbit. Differential equation of the orbit is going to be this is d square u upon d theta square plus u, that is going to be equal to minus m upon L square u square and fr, or we can write f1 upon u. Okay, f, which is function of 1 upon u. So this is the differential equation of the orbit, guys. You need to note down. Okay, differential equation of the orbit. Okay, so this is the differential equation of the orbit. Now we'll put the values. Okay, so we have already got del u square upon del theta square value, and also we have u value. So we'll put this in equation 3rd. We can say this differential equation of the orbit as a third equation, okay, as equation number 3. So it is going to be, after putting the value, this value is going to be this value is 6 upon r naught theta to the power 4 plus 1 upon r naught theta square, and that is going to be equal to minus m r naught square theta to the power 4 upon L square and FR, because in place of U square we have put the value of U value is this, guys. U is 1 upon R naught square theta square, right? So this is going to be 1 upon R naught square and theta to the power 4, okay, because that is U square. U is 1 upon R theta square, right? So this value is this. We put the value. Now this FR is going to be, we can write like this, FR is going to be this one, 6L square minus 6L square minus 6L square m r naught cube theta to the power 8 r naught cube theta to the power 8 minus L square upon m r naught cube theta to the power 6, okay, this one. So we've just got the value of FR, okay, simple calculation, just did cross multiplication, okay, this one, right? So this is this and this is this. Okay, now we can write FR value of FR we can write like this: A minus A minus A r to the power minus 4 okay, minus B r to the power minus 3. We can write like this, where A and B are constants. Okay, so where value of A is this one, 6L square r naught upon m, and value of B is L square upon m. Okay, value of B is L square upon m, okay, this one, because r naught, this 1 upon r equal to, this is we know, right? So this one, this 1 upon r equal to 1 upon r naught theta square, right? So 1 upon r square is going to be, or r to the power minus 2 is going to be r naught, 1 upon r naught theta to the power 4, right? And similarly r to the power minus 3 or 1 upon r cube is going to be 1 upon r naught theta to the power 6, right? So just we put the value, okay, this one, this was the value, this was the values, right? You just put it, okay, this one. So this is the one, this is the one, A B values we have got it, right? So now these are the values of AB, okay. So this is the so this is the equation. So we can say this equation is 4, okay? 4 equation, okay, 4 equation. Now, so this is the central force, guys. Now we'll find VR, that is potential, right? Because we have been given potential. This is the potential we have been given because that particle in 2 dimension is found to trace and orbit this, and it is moving under the influence of this central potential. Okay, so we'll find the central potential, then we'll compare and we'll find the value of A and B, right? So FR we have, then the central potential is going to be VR. This is a formula, right? VR is going to be uh, minus integration uh, FR dr, right? Because we know that F equal to central force F equal to dV upon dr, minus dV upon dr, right? Simple one. So from here we've got this one. This is a formula, guys. You need to note down. Okay, this one. So it is going to be, so now VR is going to be, value of VR is going to be, value of VR is going to be, value of VR is going to be integration FR dr, right? So FR value we have got this a minus a r to the power minus 4 minus a, okay, minus a minus a minus a r to the power minus 4 r to the power minus 4 plus b r to the power minus 3 b r to the power minus a. B r constant I have already mentioned, right? These are the values, simple one. Okay, and this is going to be dr, right? So now we'll solve it. So this is going to, so VR is going to be, VR value is going to be equal to, this value is going to be this one. Okay, so VR value is going to be, so we'll integrate it. So this is minus a r to the power 5 upon 5 plus, this is b, right? This one. This value is also minus, right? These values are minus. Okay. So and this value is going to be beta r to the power, uh, these are minus, okay, so we have done mistake, guys. So this is integration. We are integrating, okay, not differentiating. So this is going to be r to the power minus 4 plus 1 upon minus 4 plus 1, right? Minus b r to the power minus 3 plus 1 upon minus 3 plus 1. Okay, so VR is going to be this one, minus minus plus, this value is going to be, we can introduce new constant. So this value is going to be C1 r to the power minus 3 plus C2 and e to the power r to the power r to the power minus 2. Okay, right? So this is the VR. This is equation number 5. And in question we have been given VR equal to, in question we have been given VR equal to, here VR equal to C1 r to the power minus A plus C2 r to the power minus B. Okay. So this is going to be, in question we have been given VR equal to C1 r to the power minus A plus C2 r to the power minus B. Okay. Now comparing these two equations, so this is going to be, if we compare it, value of A is going to be that minus 3 is going to be minus A. That means value of A is minus minus will get cancelled, right? So value of A is going to be 3 and value of B is going to be 2. Okay, guys. So which option is matching, guys? Let me check. Option B is matching, 2 and 3, right? 2 and 3. Okay, let me just check 2 and 3. So these are the values. Okay, so this one, A and 3. Or we can write this one. This is the one. Okay, so 2 and 3, or 2 and 3, or 2 and 3, or 3 and 2, same thing. Okay, so this is the answer. You can also write this like C1 r to the, because these are constant, right? So this value equal to A equal to 3, it would be equal to 2. Okay, or A equal to 2 and B equal to 3, same thing. Okay, so this is the answer, guys. So option B is the correct option. Okay, guys, so I'm going to stop here. And also, guys, I would request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures, which are going to help you to crack the exams related to physical science. Okay. And also, guys, please share my lecture details with your friends, so that they will also be able to watch my free live lectures and will be benefited from it. Okay, guys, thank you so much. Bye now.